All right, page 28, we'll continue with our examples, solving the equation using the multiplication or division property of equality. So we're either going to multiply or divide both sides of the equation by something. For example, in this first one, 6p equals 12. It's 6 times p, so we're going to undo that by dividing by 6 on both sides. And those will divide out, which is what we want. And I get p by itself on the left, and then on the right, we would get 2 when we simplify that. And the next one, again, we're looking at multiplication, so we're going to undo that with some division, dividing both sides by -10. And on the right, we'll get p, which is what we're aiming for, we're forcing to happen. And then over here on the left, we have 2 negatives dividing, so this will become a positive answer, and it will be positive 12. On the next row, this is one I put in here to remind us that we're thinking about it's -1 times h, or you can think about it as h divided by -1. And it's because 1 is that special situation where if we divide or multiply by it, it's going to be the same. So I can think about dividing both sides by -1. And that will leave me with a positive h on the left. And then on the right, I would end up with a positive 17. In the next one, here we have a divided by 4, so we are going to undo that by multiplying by 4. So I will do 4 over 1 on both sides. And I'm going to put that -12 over 1 just so it's easier for me to see what's happening with my numerators and denominators. I don't get those confused. So we did the 4 here, and that's going to undo, right? Those will divide out. So I will have just a on the left. On the right, I'll have the positive 4 times the -12, which will give me a -48. On the bottom left, we are multiplying there, right? 6 times q. So we're going to undo that by dividing by 6. So 6q divided by 6 will be the same as 0 divided by 6. Those divide out. We get q by itself on the left. And then on the right, that's when it would be 0, right? We are not actually dividing by 0. So this one is okay. It's not an undefined situation. And then on the bottom right, I'm dividing by -10, so we are going to multiply both sides by -10 to undo that. And again, I'm putting those integers over 1, so I remember where the numerators and denominators are, and I don't get those confused or interchanged when they're not supposed to be. Those -10s will divide out, which is what we wanted. So we get the v by itself on the left, and over on the right, negative times a negative will be a positive, so 40 on the right there. All right, so I'm going to pause before we go on to the next page. So continuing on page 29, we're doing a little bit more new information before we look at additional examples. And this is going to be kind of a an umbrella outline on how to solve equations so that you have all those pieces. And this should be a reminder of all the things that we were learning in Math 38 or your most recent math experience. So a reminder that the linear variable in one equation, so that means we're going to have x is my variable, a, b, and c are real numbers, but a cannot be equal to 0, because if it's 0, then we would lose that term that has the variable on it. So we want to have something times x plus another something equals something. That's going to be a linear equation, and that means it's degree 1. That's because x has that invisible exponent of 1. So, strategy for solving these in the general format. This is the checklist you need to be thinking about. So we're going to clear the equation of fractions or decimals by using the least common denominator or power of 10, respectively. And I will explain more about that when we look at the examples. Simplify each side of the equation with the equality property. Oh, no. Sorry, with the distributive property. Yes. Sorry. And then collect like terms. So we get rid of any parentheses with the distributive property, then we collect like terms. Isolate the variable term on one side of the equal sign using addition or subtraction. So get all the variables on one side, and then all the constants on the other. And then in step 4, we're going to isolate the variable completely by using multiplication or division. And then we're going to check our answers. And we always use the original equation to check your results. And remember, we've got to get a true statement for it to be a solution to the equation. Now, there are some special situations that we can run into when we are solving linear equations, which we really didn't touch on in Math 38 if you took that. We looked mostly at the situation where there is a single solution, and that is called the conditional equation. So pretty much you've been dealing with conditional equations if you just had Math 38. But there's these two other possibilities. One is an identity, which means that every solution works. And that means that there are infinite solutions. And the third possibility is a contradiction, which is no solution works, so there are 0 solutions. So conditional equation means one solution. Identity means infinite solutions, and a contradiction is 0 solutions. So the possibilities when I'm solving an equation is I can have one solution, 0 solutions, or infinite solutions. And we'll talk about how we know which of those situations we are going to be in as we look through some examples on the next page. So I'm going to pause and we'll get all flipped over to page 30. So moving on to page 30, we are going to look at some examples. Now this page, these are going to be conditional, meaning these should all have one solution. And then on page 31, we will get to a few examples that could have 0 or infinite solutions. All right. So if we're thinking about the checklist on the previous page, we first want to get rid of any parentheses. Well, these first few, we don't have any parentheses. So we can skip down further into the list and get all of the terms that have the variable on one side and all of the constants on the other side. So on this top left one where we are solving for C, the first thing we're going to want to do is move the 2 over to the other side of the equation, because then I would have just variable terms on the left and just constants on the right. And since it's added, I'm going to undo it by subtracting. So I'll subtract 2 from both sides. That will give me C divided by 5 on the left and 2 on the right. And since it is dividing by 5, I am going to undo that by multiplying by 5. So 5 over 1 times C over 5 is going to be the same as 5 over 1 times 2 over 1. And those 5s will divide out, leaving me with C only multiplied by positive 1 on the left. And then on the right, I will have 10. Now, we always want to go back and check solutions. And this is how we verify that our work is correct, because it's really easy sometimes to lose those negative signs or do something silly and say, you know, that 4 minus 2 is 1 or something like that. And, you know, this going back and checking your answer will catch those kinds of mistakes. So if I'm putting in 10 and I'm checking this, so I go back to my original equation, so leaving the parentheses for C, plugging in 10 for that. So 10 divided by 5 would be 2, so I've got 2 plus 2 on the left. I'm checking to see, does that equal the right-hand side of the equation, which is 4? So I get 4 equals 4, so yes, that is a solution, and that is my work that shows that I checked that it's correct. Let's see. Let's look at the one that's beneath that one. So one that has variables on both sides. So looking at 2w plus 10 equals 5w minus 5. So I'm going to change that subtraction to adding the opposite so I can move things around more easily. And I am going to move my variables to the right side. You can choose either side. There is no wrong answer here. So if I want to move my variables to the right, that means I've got to move the 2w. Since it's been added, I'm going to subtract 2w from both sides. So when I do some simplifying there, I'll get 10 on the left, 3w plus negative 5 on the right. And then now it looks a lot more like the first one we did, where we're going to want to undo this. So if we add 5 to both sides, then that 3w will be by itself, because negative 5 and positive 5 add to 0. So I will have 3w, and then over on the left would be 15. And then it's back to one of these single-step equations, where I only have to undo one operation to get the w by itself. So we are going to divide both sides by 3. And we'll have w is 5. Don't forget to go back to the original equation. So I'm going to have 2 times something plus 10. I need to see if that's going to be the same as 5 times something minus 5. So the something that we got down below there was 5. Positive 5 is our solution that we are testing. So I will plug that in there. So on the left, I'm going to get 10 plus 10. And I'm checking to see if this will be 25 minus 5. So we would have 20 and 20 on both sides. So that is a true statement. So I am good with that solution. It works in the original equation. All right, the one below that is actually a little bit easier than the one we just did, because it's clear that if I move the x's over to the one side, that I will have just constants on the other. And the previous one, we had to move both types of terms. So it can sometimes, oops, sorry, minus 2x from both sides. So I'm going to subtract 2x from both sides. And then that becomes 0, so I have just 10 on the left. And then on the right, we would have 2x. And then I'm back at a single step equation. The 2 is multiplied by the x, so I'm going to undo that by using division. Those divide out. We get x on the right and 5 on the left. And then we go back and double check. So if we do 2 times something plus 10, is that going to be equal to 4 times that same something? And we plug that 5 in wherever we had an x. And we do the order of operations to see what we get. So on the left here, we would get 10 plus 10. And will that equal 20? So 20 is is that equal to 20? It is, so that is a